Today's science lesson is brought to you by Rudy's Country Store and Barbecue. Next in line. Hey guys, good to be back with you. I'm really excited about the science lesson we're going to have today, and it has nothing at all to do with the science. It's because there's coffee in the Rudy's cup. That's right, I'm chock full of caffeine right now. And you know the lesson's going to be good when I got a little caffeine in the Rudy's cup. Okay, let's get started. Okay, so today we are looking at the Junkie Review, the 8th grade Science Star Review, reporting category 3. That's Earth and space science. So everything about the Earth itself and then how it relates to the objects out in the universe. We're going to cover the 8, 7A, B, and C today during this flipped lesson here. We got day, night, and seasons, lunar cycle, and tides, and we'll try to get through it as quickly as possible while still going over the concepts, not just giving you the answers here. So, first thing we're going to do is we need to be reminded again about the important vocabulary words and basic ones, even like rotation and revolution. If you understand the difference between these two words, it's going to help you a lot in understanding day and night and seasons. And so that's what we need to make sure we understand those. Okay, so rotation, just to review, is the spinning of the Earth around its axis. These two wooden pegs obviously represent the axis, and the tennis ball is spinning around those. That's rotation. Okay, revolution is when you have the Earth traveling around another object like the sun. You notice the axis stays in the same direction, but we're talking about revolution now, moving around the sun. And when you combine the two, you get rotation and revolution, which gives us not only day and night, but also the seasons as well. Okay, quick review there. Let's go on to the actual questions. The time it takes for the Earth to rotate on its axis. Waco rotates from day to night and back to day again. That is 24 hours. Okay. Time it takes for the Earth to revolve around the sun. Gotta hang on to my tennis ball here. Right? 365.25 days. In the northern hemisphere. Okay. And it is in North America, so it's experiencing winter. Okay. The day and night cycle on Earth is caused by rotation of Earth around its axis. Okay? The Earth is closer to the sun. This is interesting. It's not what you would think. The Earth is closer to the sun actually in winter and farther from the sun in summer. You would think the exact opposite was true, but that means that this varying distance from the sun to the Earth is not the reason for the season. It's not because we're closer to Earth that makes it summer. If it were, then being closer to Earth would make it summer, but in fact it's winter. So it has nothing to do with how close the sun is to the Earth at any given time. Seasons are caused by the 23.5 degree tilt of the Earth's axis and the revolution of the Earth around the sun. Okay, so we want to know now how you would represent the Sun-Earth relationship with a basketball and a tennis ball. And we're concerned only right now about the cause of day and night, not the seasons. And that's important, we'll see in a moment. So in this situation, the basketball will represent the sun, and the tennis ball will represent the Earth. Okay, so again, just day and night. For day and night, would we lift the tennis ball off the table? Yes, we would. I'm going to put a check instead of circling it, okay? The reason we would do that is because in order to rotate the tennis ball, it's kind of hard to do when it's on the table, so in order to make it rotate, yes, we do want to lift it off the table, okay? Do we want to rotate the tennis ball on the axis? Yes, we do, because that is what causes day and night. The side facing the sun is lit up, and the side facing away is night. And so the fact that the Waco here rotates between daytime and nighttime, that gives it day and night. Okay, so yes, we want to rotate. Yes, we want to rotate the tennis ball on its axis. Do we want to rotate the ball clockwise? Now this is an important distinction. I've seen it asked on the STAR test before. If you look at the top half of the Earth rotates this way. So if you think about a clock, that would put 12 o'clock here. In fact, we'll just do that real quick. If it were a clock, we'd have 12 o'clock, 1 1 o'clock, 2 o'clock, 3, 4, 5, 6, 7, 8, 9, 10, 11. So normally the clock hand moves, if we have the clock hand, right, it moves this direction. That's clockwise. However, that is not how the tennis ball rotates. It actually rotates the other way, like this. So that's not called clockwise, that's called counterclockwise. Okay? Counterclockwise. It actually rotates in this direction. Okay? Alrighty. Moving on from that. Do we want to rotate the, so that's a no. Sorry about that. We want to X that out. And you break your pencil. Do we want to rotate the basketball on its axis? No. We do not want to rotate the sun on its axis. We want to rotate the earth on its axis. So that would be a no. Do we want to move the tennis ball around the basketball? And this is why I said it's important to remember that we're only doing day and night. Remember that moving the tennis ball around the basketball is what causes our seasons. And we're not talking about seasons right now, okay? We are talking about just day and night. So just this. So no, we do not need to move the tennis ball around the basketball. Do we want to rotate the ball counterclockwise, the earth counterclockwise? And that is yes, and we saw that just a moment ago. Okay, flipping over to page 3. Now we're going to do the same thing, but we're going to do it with a volleyball and a golf ball. So let's just say the golf ball's here because I think the copy maybe got rid of it. Golf ball, volleyball, okay? And instead of doing day and night, we're going to do the seasons, the cause of the seasons of Earth. And again, that's the Earth moving around the sun, right? So the volleyball will represent the sun, and the golf ball will represent the Earth. And since we're calling it Earth, that's a proper noun. It should be capitalized there. Okay. Are we going to rotate the golf ball on its axis? You don't have to do this because we're not concerned about day and night. So if we're just doing seasons, then we're not going to be concerned about rotating the golf ball. Now in real life, the Earth does rotate as it moves around the sun. Okay, so it's doing this as it moves around the sun. But for this model, we're not needing to do that. Do we need to tilt the axis of the golf ball? Yes, because that's a big part of the fact that we have seasons. The tilt causes the uneven heating of the Earth. Okay. Move the volleyball counterclockwise around the golf ball. No, the sun does not go around the Earth. Do we want to rotate the volleyball on its axis? No. Do we want to tilt the axis of the volleyball? No. It's the Earth, not the sun, that has a tilted axis. Do we want to move the golf ball counterclockwise around the volleyball? And that answer is yes, just like this model here. Okay? We're moving it counterclockwise. Okay? So that's correct. We do want to do that. All right. Looking at this picture now, we're going to label, we're going to basically use the diagram to answer these questions, okay? So label below for the northern hemisphere. Position 1, the northern hemisphere's position 1. The northern hemisphere is, well, I'll tell you what, before we answer that, one thing I want to tell you to do is always find summer and winter first. So if we're talking northern hemisphere, we're going to go ahead and label the top half northern, the bottom half southern. Okay? Top half northern, bottom half southern, top half northern, bottom half southern, top half northern, bottom half southern. Okay? So now, the northern hemisphere axis is tilted towards the sun, which means northern hemisphere is in summer, southern hemisphere is in winter. Now, once you have done this, guys, everything is just simply thinking about the calendar. This is the next position. What comes after summer? After summer, we go back to school in the fall. So it's northern hemisphere fall, southern hemisphere spring, which makes sense because after their winter, they should have spring. After fall is our winter, and they have summer because they're tilted towards the earth, towards the sun. And then after our winter, we have spring, and they have fall. So an easy way to look here at the relationship is that they're always opposite. When we're in summer, they're in winter. When we're in fall, they're in spring. When we're in winter, they're in summer. And when we're in spring, they're in fall. Okay? So position 1, the northern hemisphere, is fall. Between 1 and 2, do the days get shorter or longer? So here's 1, here's 2. We're going from fall to winter. Remember, winter has the shortest days. Okay? Winter. So, if winter has the shortest days, then from fall to winter will be getting shorter. Okay? Between 2 and 3, here's 2 and 3. Do the days get shorter or longer? So we're going from winter to spring. Remember, winter is the shortest. So moving to spring, we're getting closer to summer where they have the longest days. Okay? So these days are getting longer. Between 3 and 4, do the days get shorter and longer? So between 3 and 4, we're going from spring to summer. Since summer has the longest days, the days are getting longer from spring to summer. Between 4 and 1, do the days get shorter or longer? So between 4 and 1, from our summer to our fall. If summer's the longest, then the only thing it can be doing is getting shorter. Let's see, all these are northern hemisphere, right? Yes. How much time passes from position 2 to position 1? Position 2 to position 1. Okay? Time-wise, remember that this takes 365 days or a year, right? And so if we break up a year into 4 parts, then each time is 3 months. Okay? So the time between each season is 3 months. And if you think about that, that makes sense, right? Summer is, where's summer? June, July, August. Fall starts in September, October, November. Winter is December, January, February. Spring is March, April, May. And then we get back to June and start it all over. Okay? So how much time passes from position 2 to position 1? 3 months. Plus another 3 months is 6 months. Plus another 3 months is 9 months. So the time that it takes to go from winter to fall is 9 months. Okay? And we're going to stop there. We'll come back and do 8.7b lunar cycle next.